Hello everyone, I am Audit. This is a problem from Australian mathematics competition. This is a question about remainders. You can think it over. Pause the video, think it over for a while. I will give a solution soon. Yeah, if we know this, because we need the remainder be same, right? Same remainder. Because it's the same remainder, the range should be within 0 to 14, also within 0 to 26. So what's the common part? That's from 0 to 14. First, we find the range of the remainder. Yes, it can only be from 0 to 14. It cannot be 15, say 25 or 21, because it's not within this range of 15 remainder.
Yeah.
Yeah, that's it. First, we find the remainder should be from 0 to 14. Good. Then next, okay, I clean the screen. Okay, suppose we've already found a number. Doesn't matter anymore. Yeah, from 1 to 1000. It's divided by 15. That equals something. Doesn't matter. That has a remainder. Doesn't matter remainder. Say remainder is 3. Also, we found another division. Yeah, this number same. Okay, these two numbers same, right? Same number. Yeah, same number divisible by 27. 20. So this also has remainder 3. So from here we know. So doesn't matter this number, because both have remainder 3. If this number take away 3, what happened?
Pardon?
Okay, I said, yeah, this number. So this number from here. This number minus 3. What's some property about the result? This result.
Oh. Okay.
Yeah, before, if I do not minus 3, so there is a remainder 3, right? If I minus 3, what happened? Say, for example, don't worry. So 7 divided by 2 equals 3. The remainder is 1. If I use 7, minus is 7, minus the remainder 1. So the result is 6. When we use 6 divided by 2, it's divisible.
Yeah.
Yeah, no remainder. Yeah, this is example, okay? So,
I think the property for the first one would be it's always divisible by 15.
Yes, that's a feature. Okay, property of feature. Yeah, that's right. Okay, because the same number from here and from here, that's the same number. If we can divisible by 15, minus 3. Okay, minus 3. It can divisible by 15. It's also divisible by
27.
27. Good. Yeah, that's easy. Yeah, because if there are remainder, we can do nothing. Without remainder, easy for us. Now it's easy. Now we only focus on the number minus 3, the result. Don't worry about the number. When the number is divisible both by 15 and 27, that means it's a multiple of 15 and also multiple of 27. Both of that. So this number must be something minus 3. This number must be the common multiple of 15 and 27, right?
Mm-hmm.
Common multiple, yeah. So in order to find out, because there are a lot of common multiple, so in first way, we need to find out the least common multiple.
Yeah.
Yeah. So what's the least common multiple of 25 and 15 and 27?
135.
135, yes. Least common multiple. Good. 135. So if we find the least common multiple or other multiples, we can find easily by using times 2, times 3, times 4, keep going. That are all the common multiple of 15 and 27, right?
Yeah.
As long as we know one of that, the least common multiple, the smallest one. So all the big ones, just times something, a whole number, yeah. I will get others. Okay, we start from 135. Yes, good. We draw a table. Okay.
Can I ask a question?
Yes, sure.
Can I start with like can I start off with like 0?
Yeah. It's awesome. So if 0, you're right. If it's 0, that's just 135 times 0. Yeah, let's say 0. Yeah. This is all the possible. Yeah, you're right. So 135 times 1 is itself. Yeah, you're right. So times 2, that's another one. Okay, good. 270. Yes. You're right. So when we draw the table, yes, you're right. Okay. I just list all the numbers in the table. Yeah. Okay, we record this one as choose another color. Okay, this one as a remainder. Okay. Remainder can be, we already know that it can be 0, 1, 2, 3. Keep going. I just put dot. Okay, until 14. That's all remainder possibility, right? Yes, like you said, the first common multiple can be 0, right? So why is 0? Because the number is from 1 to 1000. No 0 here. So the first one, the candidate is 1, right? 1 divided by 15, the remainder is 1. 1 divided by 27, the remainder also 1. It works, right? Yeah, that's a 0 multiple, yeah. Okay, good. So also 2, 3, keep going until 14. There are the 14 numbers which is the answer for this question, right? 14 numbers. Okay, then we keep going. So I put a multiple here. Sure, another. Yeah, this is a remainder. Okay, I put here. Just I write down 135 times 0. Start from here. So this one, 135 times 1. Yeah. As I said before, we just need a number which is common multiple of 15 and 27. Then plus the remainder to find the number. Because some number, say minus the remainder, before we is minus 3, right? Equals the common multiple, 135 times any number. So when we move the minus 3 to the right hand side, that means plus 3, right? To plus 3 to get the original number. Yeah, we want to find this number. How many this number are there? Yes. So plus 3, because this is a special case. In fact, it's plus the remainder, right? And then the remainder, the range between for the R, the range is from 0, 1 until 14. All works. Yeah, this starts from 0, right? 0, 1, something. Yeah, keep going. Yeah. So first we already solved 135 times 0 plus the remainder. This is first row. Then we change this one to 1. Okay, when this is 1, already recorded here. So 135 times 1. Now we need plus the remainder. Remainder is from 0 to 14. So the first one is 135.
Yeah.
Second one plus remainder 1. So 136. Now keep going. 137. So until the last one, 135 plus 14. Okay, this is 149. Okay. All the numbers in this table are the candidates for the question here. Okay, keep going. 135 times 2. Because we know the largest one should be less or equal to 1,000. So we just find out the last multiple of 135. We just use 1,000 divided by 135. See how many multiples are there? Okay, this is 5, 7.
7, I think.
Yeah, maybe 7. Yes, 7. If it's 8, it's more than, yes. 7, 8 is more than. So 5 times 7, yes, less than 1,000. Good. So the last one, it is 135 times 7. Right? We can fill in all the numbers here. So 135 times 2 plus remainder, that can be 270 and 271, 272. That keep going until last one, 270 plus 14, 284. Right? Keep going. We don't need to write down all the numbers. We just find the pattern. Pattern is most important here. If we know the pattern, then every row we know that. Okay, we can fill in all the numbers, but we don't need to do that yet. Because we only need the total numbers of these numbers, right? Yeah, we don't need to write down all the details. Okay, so we only fill in the last column because this one we need to check. Yeah, 135. Let me check 135 times 7. What's the result? It cannot exceed 1,000.
Mm-hmm. So 945, I think.
945, right? Okay, because the last one should be 945 plus 14. If it's more than 1,000, it doesn't work. Okay, make sure the last one should within 1,000. So if this number is still less than 1,000, it's still good for us, right? So now we only count how many rows are there, right?
Yeah.
Start from 0. This is row 0, row 1, row 7 until last one, row 7. How many rows are there?
8.
Yes, 8 rows. So for each row, how many numbers are there for each row? Except the first row. So all the other rows, there are 14 numbers, right? Or 15 numbers, right? Start from 0 to 14. There are 15 different numbers. So altogether, there are 15. Each row 15 times 8 rows. But for the first row, because this first one is empty, right?
Yeah.
Minus 1 for the first one. The zero is not within 1 and 1,000. Yeah. So the answer is 15 times 8 minus 1. Yeah, that's the answer. The answer should be 119.
Yeah.
Thank you for watching. See you next time.